So now I'm trying to create a input program. Okay, so right here in our slides over here, eventually I would have a program at the end to convert Celsius to Fahrenheit function. Okay, so I read this as a project or a homework for you. Okay, so now here I actually demo different things. Right here, let me demo different things. So here, let me demo. If I need to convert, pounds, convert pound to kilogram. Okay. So if I need to convert pound to kilogram, so I can have a value like a weight 1. Weight 1 is actually 34, and if the unit is kilogram, I'm sorry, pounds. Right now, I need to convert it to. Actually, I need to convert it to pounds, right? So my pounds 1, it will be 34, and then multiply by 2.205, right? That's roughly 2.205, and then I print pounds, pound 1. So that's the simplest print. We already know that, right? That's something we already know. Okay, just print it. It's 74.97. Okay, now the easiest one, right? And then if I need to put something here, I can say weight 1, and then pound 1, and then here I have it is 2.205. Okay, and pound 1. I want to print these 3 numbers. But if I put this like here, this 3 number being printed, I will end up 3 number like this, right? But there's nothing to tell which one is what. So here I would say, I say weight, okay, and then comma, this one. And then at the end here, I put something right here. I put something here, and I say this one's kilograms. And I use capital G, K, okay, kilograms. And then I need to have a time multiplication symbol. Okay, and leave a space in front of it and 1 after it. And then the number. And then is so many pounds. So at the end, I need to put the pounds mark. Okay, so that's the way. If I am so stupid, I try to put this here. Okay, that's the way I print it. Okay, so weight 34 kilogram times 2.205 is this much, right? So the first thing I want to convert is the pounds. So the pounds, I don't like it. I have a 3 letter. It actually is not what I want. So here I just search in my internet site. So here I say pound symbol and then say Unicode. So Unicode has this pound symbol. And I don't like the actually I don't like the euro pounds. I should say I should try. It's not euro pound. I want the weight. I want to say American pounds. No, there's nothing. Let's see, this is still the dollar pounds. Okay. Pound sign. Unicode. I still this concept. There is a special pound sign Let me see, pound side. Let me try another one. LPs equal. Oh, wait, let me see if this works. Oh, this is mass. Okay. So this one increase pound symbol. So there is a pound symbol. Wait. It's still not the same. Okay, there is a pound symbol actually right here. It's a single symbol. Okay, this one LB is a single symbol. So that's the one I actually want to have. You know, you can search through internet if you need some special symbol. You can put this, and then let's say that is Unicode for LB. Oh, okay, it's actually 2114. Okay, so right here I don't have these pounds, and I say backslash U for Unicode. Okay, 2114. Okay. So that actually Unicode is for all kind of symbol, right? So if you like my Chinese name, I just want to show you that you can search through internet to get the number, and then you put it 5468, and then you can put it out 5468, something like that. 5468. Okay. I just want to teach you how these different numbers or symbol can be found, even Chinese letters can be found. Okay, so here's a pound mark and my name, but my name actually used this is not something I want to do. So the pound mark actually being found. Okay, here's a pound mark. So this one is actually very stupid printout format. Okay, it actually just connected everything together. So there is another way we can print. Okay, this whole thing I can also print like this. I can actually copy this one and put it at the end outside, put it here, and then I can actually do plus sign, plus sign, plus sign, plus sign. Just put a lot of plus sign to connect them together. Okay. Okay, and here I say this one is called string 1 equals this. Okay, but this number cannot be converted for string, so I need to do actually do str parentheses like this. Now convert a number to a string. So here I have str parentheses. Okay, and then here I have str parentheses. Okay, and then I can print the whole string together. So here I can print this one string1. That's what I have. So the second format should be the same as the first one. Okay, it should be shorter because there is no space, leading space, ending space before or after it. Okay, so it actually will be shorter, more compact. Okay, so that one actually is fine. Okay, because this pound it will save some space, insert some space in between. So this one is more compact. But in the second form we can print it. Well, but this guy actually still quite stupid. Still not the way we want to have it. Okay, so now let's actually copy this guy down again. Okay, copy this guy down again, and I want to have some sort of formatting for it. Okay, I want to have some sort of formatting. Instead of putting it like this, I want to have some formatting. And what I can do is actually and this this number I want to get the pounds to kilogram. So pound, oh I'm sorry, it should be kilogram to pound. Kilogram to pound. So you search through the field, oh I want to use this number. More accurate, right? So I put it here. Instead of using 2.0, The one I use is the one I used before for this 2.205. I just want to be rough. Okay, but here I want to do this. But this, every time I put a string, that's actually inconvenient, right? So what I will do is actually convert this into a formatted string. So I can put it here. First one, this one, weight. I can put a %f. And then this one, I just take out this this whole thing, this whole weight things. Okay, take out this whole weight thing, and at the end of everything, I put a percentage sign, right? And then over here, I put weight 1. Okay, I put a weight 1 over there, and then next one, multiplication. Okay, multiplication can be connected with the kilogram. Okay, and the next one, this number. Okay, this number actually can be put here, and then here I put the percentage sign f. Okay, and then I cut this number back to here to the end again, and put it down here. Okay, and then I connect everything together here. Okay, is, and this pound 1, I also just remove it. So here I put another number, pound 1. Okay, this is the way actually I'm trying to teach you how to put everything together. So this one, pound, is also percentage f. Okay, so what happened is that after this arrangement, what happened is that I put the 3 number I would like to that are not string over here. So this one will replace the percentage f. This one will represent the percentage f. This one will replace this percentage f. And percentage f means a floating-point number. So it actually is a real number, some sort of real number, floating-point number over there. So let's see how this works. Okay, compared to the previous one. Let's see how this works compared to the previous one. So let me run, and then pound to kilogram. Oh, I haven't printed this as string 2 yet. Sorry. So I put print string 2 over here. Okay. Okay, so it's something like this. And as you can see here, this is ugly. I don't want it to be this long, right? So this string 2 is still ugly because it gives me the 14 point, but too many digits. Okay, I really don't need that many digits. Okay, let me copy. Copy this down, and I put it into string 3. Okay, so as you can see right here, I'm step by step refining the format. Okay, so here I have this percentage f, that's the formatted floating point number, right? Now I want it to be, this one should be 6.2 would be fine. What is 6.2? 6.2 actually means I have a 14-point number, right? I have a 14-point number, and then actually this 14-point number I want to replace it. So my number is actually 34.000 or something, right? So 6.2 is that totally I want to have 6 space, and then 2 digits after the decimal point. And then the third one, so this is 1, 2, 3. The third one is a decimal point, and then 4, 5, 6. So totally I'm going to print space 34.00. That is totally the width is actually 6. 2 is 2 digits after decimal point. Okay, that's the format I use. Okay, so now actually let me clean this. Okay, since I like a 6.2, let me put everything with a 6.2 format and see what happened to it. Okay, so this one is 6.2, 3 different 6.2 number. Wrong, and then okay, so this actually cut down to 6.2 format, right? And what should I do? This one actually the space is too much, right? And it has a totally it's just 3 digit, 4 digit, including the decimal point, but it is 2 more space. So I can just drop down to 4.2. Okay, so that one is be shorter. This one has one extra space. This one has one extra space. So I can tune it to 5.2 to be very compact, right? Wait, okay, so this is quite compact with this, okay? But this one actually I want to have more precision because 2.2 doesn't show me the precision I want. Okay, so it's 1, 2, 3, 4, 5, 6, 7. So it's 7.5. So I actually, for the weight resolution, let me do 7.5. I give you more resolution for the for the ratio, conversion ratio. Oh, this is better. This one is better. Now I have this, so let me save this one, pound kilo, number 1. So let me create a new project, new file, I'm sorry, new program. So this one is pound to kilo, number 2. Okay, now I created pound to kilo number 2. Now actually I copy this whole thing over. No, I don't want that everything. I just want to have these things. I just want to have the right format for me. I don't need anything else. Okay, now I'm going to do the following things. Now actually I don't want to put a string 3, so I cut this guy out. Cut this guy out and then put it here, right? As a print statement. Okay, and then this I just delete it. Okay, and weight 1, pound 1 actually is too long. I don't like the variable name. I put W1 and pound 1. Okay, so now I have this one, pound 1 equals this one equals 10 pounds. Okay, and then W1 equals pound 1 times 2.20462, right? And let me do this. Let me actually copy this guy for 10 times. So the way I'm doing it is stupid, okay? But I'm just trying to teach you how program can develop step by step, okay? And why I'm doing this, why I'm doing that. I'm just trying to give you some idea of why a program can be step by step refined, and then you will get a better idea of what it is by such a process, and knowing each function how to use it. Okay. So here I have this, and then 7, 8, and then 9. Sorry, 9. So you can see this is very tedious, right? And then a programmer shouldn't be doing this kind of stupid work, right? So later we will refine it, and you will see how programming can help you on this. Okay, so I have a W1, W2 like this. Okay, let me copy. Okay, let me copy like this. Okay, and then put here. Okay, and then put down 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here I continue to change 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when you got a good format, okay, you do some experiment, you got a good format, and then you just duplicate it. That's one stupid way to achieve things, but it actually will be solid. Okay, so here I finish this, right? So I have all these. That's print it. Okay, let's just print this way. Okay, so the value are all 10 because I only assigned 10 to there. Okay, so I should change it to 20. Right here 30, 40, 50. I'm sorry, this one is P. And then 60, 70, 80, 90, and 100. Okay, so I actually increase in pounds every time, and then let's run it. Okay, so actually this is like this, right? This is time this is this, right? Okay, so this one actually is from weight to pound. Actually, my calculation is from pound to weight, but it's okay. This actually, I have this print function, okay? So the next one actually, I should add a banner, okay? So I don't want this weight over here actually is ugly. Right? I don't actually want this weight kilogram, and also this pounds fine, but is and multiply. Actually, I want to adjust. Okay, I want to just adjust this. So let me actually save this one as conversion to this one pound to kilo 2. Okay, actually I save this pound to kilo 2. So now I actually new another one called pound to kilo 3. Okay, now I actually would like to make a table now. So I actually just copy this one, copy this over, right? I want to make a table and put it here, okay? But this time I don't like this, this actually, I don't like to print this. I just want to print weight and pounds. So I started from pounds and I want to convert it to the weight in kilogram. And then the pounds number is fine. So I have this is a 5.2, this one, and then I put this one with some space. Okay, so right here I put actually put percentage sign 5.2 F. Okay, something like this. And then this time to use so many solving line in this number 2 actually is quite stupid. Okay, this is actually purely stupid. So actually I just copy these things over here. And here, in order to make it repeat, okay, so what I should do is actually right here, I should define a function called LB to kg, okay, and I put in the pound, and then this pound, let me see, I actually I should return this pound time 2.20.462. Okay, so here what I have is I have pound 1 equals 10, right? I have pound 1 equals 10. So my pound 1 over here. And what I need to do is actually I even don't need to save the W1. So right here I say I put it pound to kilogram and put this number 10 over here. Okay, so here I would have this one is more advanced already, okay? So this one, that's why I started with simple one. So this one replace this one with a pound mark. This one replace this one, right? And this one actually you put the 10 over, I'm sorry, it shouldn't be put 10. You should put P1 over there, okay? So here I should put P1 instead of 10. 10 is a fixed number. So here I put my P1 over here, okay? I have a P1, and then P1 converted to kilogram. You will put a P1 10 over here and times this number, and you will be returned from this function. So this pound to This pound to kilogram function actually is a function. A function f, you put a p in the pound and then return kilogram. So you have 10 over here. You should have I'm sorry, to a pound to kilogram. Or actually it should be divided. It's actually not multiplied. So here, let me change it a little bit. Here should be division. Should be division. Did I make a mistake? Oh, actually last time kilogram times the ratio. So here actually is a division. Okay. So pound to that actually is that. So you provide 10 over there. You divide it by 2 point this, and then get the kilogram number. So this one, this pound should be this kilogram, and that's wrong. Okay. So a single one, 10 pound equals 4.42 or 4.54 kilogram, right? But I miss a kilogram mark. Okay. Since I found it, I already found the pound mark. So I should also do kilogram Unicode symbol. Okay. So kilogram Unicode symbol is actually what? This one is square kg. Okay. I want a kg. Is this square kg or square or kg? This one is kg. So kg is a 338 F. So kg is 338 F. So 338 F. And put a U over there. Let me check again. Okay. That's a kg mark. 338 F. Yes, 338 F. So that's wrong, this one. There's a single symbol for kilogram. So this one is what? Let me save it. Save all and run. So let me run this kilogram 3. Okay, I find the kg mark. Okay, so that actually is the pound to kilogram. But here I only put a 10. I need to repeat for 10 times, right? If I put this one, for 10 times, that will copy this for 10 times, that would be stupid. So what I can do is like for I in range 1 to 11, and then I print this P equals I times 10, right? And then I actually put this P over there, and then here I put this P over here. Okay, so that actually will calculate. Here it will calculate. This P will be 10, 20, up to 100. Okay, so here we have a range function. What is a range function? A range function, if you have a range function and then you put a 5, say, this one will generate a number 0, 1, 2, 3, 4. So a single value is the ending value, but not including it. So 5 not included. So it starts from 0 up to 4, but not including 5. This one is the ending value, but not included. So inclusive of this one. That's a 5. So if I put two numbers, in my range function, I put two numbers. That is one range 1 to 11, but 11 is included. So you have the 1, 2, up to 9, 10, and then 11 is not included. Okay, so this one actually generates a number from 1 to 10, right? From 1 to 10, and then you put into that function, and then you times 10, and actually it can run. So let me run this one. So right here, oh, that's not bad. Okay, it actually convert 10 pound, 20 pound to up to 100 pound. Is that okay so far? It is okay so far?
还可以。 有一些换来换去有一点快，不过没关系，我们到时候再看那个，然后会问一下李永清怎么 detail。可是我们有点知道你在干嘛，我觉得这样还不错。
OK， 所以这个 range 现在就是从1产生到10，然后每次拿一个 i 出来，对不对？然后它 i 乘以10就产生一个 p， 然后把 p 放进去，就会得到10，然后10除以2.2几，这个有没有？这样你就可以产生这个 table 出来。但是这 table 看起来还是丑丑的，对不对？ It's okay. The table is ugly. We will refine it later. Now the important part is that okay, I started from. You can shut down. Mute it. Okay. So this one actually is starting from 1 to 11. So if there's only one number, that will actually starting from 0 up to that number. Okay, but that number is not included. So I put 5. It only generates 0 to 4. Okay. And so for example, this one, if I only put one number, I can also do this. I can also do this one should be 10. I can put 10, right? But here I should have like I plus 1. So I plus 1, the first time 0, it will be 1 times 10. And then the last one is 9 plus 1, it will be 10 times 10, it will be 100. So this one is effectively the same with the one I use 1 to 11. Okay. So that's one number, it will be the ending number. Two number is the starting number and the ending number, but not including that one, not including the ending number. Okay. Now I told you, I teach you the 3 number system. 3 number for the range function. Okay. So 3 number is 1, 2, right? But if I do this one 10, right? This one ending 110, right? And then each time increase by 10. So I can just put this I over there. Okay, so this one starting with 10 and ending at 110, but each time step size 10. So it actually will increase from, this one will increase from 10, 20, 30, 40, up to 100, but 110 is excluded. So you actually effectively generate 10 to 100. Okay, so this one that's wrong. Okay, this one that's wrong. Okay, same thing, right? Same thing as before. Now, I'm not satisfied with this. Since I assign value to p, so why we need to generate I? We don't need the I, so I actually kill the I and I just put p over here. So this one is the right solution. We don't actually need the I. I'll just demonstrate if you don't know how to generate the range function. So this one actually give you the right number we need and right combination in one shot. Okay, so this one's look better, right? But the table is a little bit off, right? Because this one actually definitely is like 6.2 format, not 5.2. So let me do 6.2 over here. Okay, let me do 6.2 over here, and then see how it aligns. Okay, this 6.2 look better, right? But I need to have some banner, right? I want to have some banner. So let me see, let me actually put 1, 2, 3, 4, 5, right? And I want to have some banner. So let me copy this thing over. Copy over here. I want to have some banner. So right here, instead of here, actually, so here I have, see here, pounds. Okay. And then it actually is the totally 6 plus 1 is 7. So 1, 2, 3, 4, 5, 6, 6, and then I add 1 in front, so 7. So 5.2, this is 5 plus 1 will be 6. So this one actually, here I should have a kilo, but leave one after, leave one before. So these two will be matched. We're matching the string we have, okay? So that actually delete it. And then I need this banner. I need this banner. Okay, there's a kilo and then there is a pound over there. But I need a line in between. Okay, let me copy a line. So in order to generate a bunch of lines, I can put this and then minus sign let me generate about 30 of them, okay? So this one will generate 30 of the dash minus sign. So that one, actually, let me see here. Oh, it is better, right? It's a better format. So if I would like to save, put a empty line before this table, I can just actually run this. Oh, it's better, right? So here, actually, I can do this. I can do this over here, conversion table, right? And here in front of it, I say weight conversion table, something like this, right? And that would look better. Okay, so this is better, right? It's about good one for demonstrating. If you don't like it, you can put a space over here to make the unit a little bit separated. If you do that here, you need to actually add a space here and also add a space here in order to balance the format. Right, something like this. So actually, I should push pound one back, okay? And the weight table also need to be one back. Okay, so this one is what? This one is for pound to kilogram. Now, if I want to convert from kilogram to pound, this is easy now, right? This one is easy. Let's just copy this guy over. Right? Instead of putting a P, I put a K over there, and I change the name kg underline to LB, right? And I put my K over here, and this time is times, right? So I finish my kg to pound program, right? Now I actually this time I just need to copy this whole thing again over here, down there. Okay, and then now here I should put kilo, 1 kilo, but this one behind, one after. Okay, and here I put 4, so I delete 2 more, and I put the pounds. Okay, so here I have a kilogram. Since in here I change to K, right? Because it's kilogram. And here I think my this one, oh, this is okay. So I put my K over here, and then my kg over here to pound, and put my K over here. So this should be able to convert this table from a pound to kilogram to pound. But in between, I want to leave 2 lines. So I put print that was put as between the 2 tables, there will be 2 lines separated. Separated by 2 lines. This is separated by 2 lines. Oh, I'm sorry. I'm a kilogram symbol, and the symbol need to be changed. Cut this one here. Paste this one here, and cut this one here. Paste it here. So be careful. Don't mess up the format, because we spend time to adjust the format. Let me save. Let me run. Okay, so this one's kg to pound. And look like this one is off, right? So here I need to change to, the number is bigger, so I change to 6.2. And then the number of line 30 is not enough. Let me change it to 33. Okay, so this one is a good table. Okay, so after this, if you want to actually make this table a result and you want to save it, say You can just copy this one, right? You can just copy this one and then find a editor, say this one over here, right? And then right here I just pass it over here. Okay, so you can save that table right away to here if you want to save the text file for the table you generated. Okay, that's one way we can save it. And this one is kilogram to pound number 3, right? But this one actually is what? This one is actually only getting the number from, I generate a number by this range function, right? But now the next one, I would actually try to create another one. Let's call it like pounds to kilo 4, number 4, okay? Pound to kilo number 4. So this is number 3 one. I copy this function over. It's fine, okay? So let's copy this 2 function over. It's fine, okay? And then what do I need? I also needed to have that 2 format. I like that 2 format. So one format is this line. I like it. That one give me the right format for pound to kilogram. And I also like the other one. This one, kilogram to pound. I also set this to because here, and then I actually change it for unit. So the next thing I'm going to do is, for that pound to kilogram, actually I generate by table, right? But what I really want over here is that could I get answer from outside? So I can have a P, and then let me say a float, and then input. Okay, let me put two step. Okay, if I have a S equals input, so right here, enter pounds value. Okay, and then I put that S over here, convert it to flow. Okay, and something like that. And this one after here, oh, I'm sorry, I missed one. And right here, I put this S equals enter kilogram value. Okay, and then here I have a K equals flow of S. Okay, so what happens is that if you have an input, you are expecting some input from here. This S will save a string or text format, but that text format I can convert it to 14-point or real number. Same thing for here. The kilogram also is a string. So in between I put a print. Okay, now let me actually run it. Oh, I'm sorry, I should save first. Okay, save all. And now I need to run this one. This one, let's see. This one is pound to kilogram for, but then there's no problem listening. Run. How come it's only 3? Oh, 4 here. So enter a pound value, say let's say 100. Okay, it actually give you this. Okay, so this one actually for table that must be good. So that in here probably this is better. So let me cut it to this one. Same thing for this one. But I need to finish the previous one. So that here let me put 100. Okay, now let me run again. So here I have 100 pounds, right? And then here I have 100 kilograms. Okay, so that actually finished with input. So today actually we finished what? We finished first one. We have a single value doing some computation and print out, right? That's the easiest one. And then we have a bunch of value in an array, and then put into a converter, and then generate a bunch of value and put it out, right? That's the second one. And then here we have, and then here we have this one. You have the input from keyboard, go to the program, and then you print it out. Okay, so these are the pretty much the normal way of doing computing. Get data from inside, or you actually have the root to have multiple of them, or you key in from keyboard. 3, 4 different sources. Okay, and there is another source actually. There is another source. There is another source. If you want to try, you can actually do this. You can do this from mass import start. Okay, and then here I have my k1 equals random integer 100. Let me see. Oh, it's from random, not from range. So here is actually from random. So I generate number 100. So this random 100 will be generated from 0 to 99. So I need to plus 1. That will generate from 1 to 100. Okay. And then actually I put this one over, copy over. Okay. And at the end, we say this one's a random example. Okay, and right here we have this K1 and K1 over here. Okay, let's run this one. So here I still input 100. Oh, here is a position. Let me see, position B. Missing one required position argument. Wait. And then let me check, okay. Oh, it actually need to have a starting number and the ending number. So I should put actually here 1 and 101 here. Okay, sorry. It should be this form. Okay, so this one 54 kilogram will be this. Okay, so this one give you the another one input actually is coming from this one actually coming from where? From random number. So you can from keyboard, from your own program, or you generate by random number. And this one random integer is from random number generator. It generates a number from 1 to 100. And this one again not included. Is that okay so far for this random number? So this time is 52, right? If we run again, it becomes 74. So every time it will have different value. Is that okay? So the random number is like every time it keep changing. So then it will have different value to test your program whether the conversion is right or wrong. Okay. So that's the random value. So this one is our kilogram. Yeah, question?
没有，反正最后你会把那个录影的那个拿来给我们嘛，对不对？
Yeah.
因为我觉得中间有一些地方我们不是很清楚，可是因为快过去，所以我想说到时候叫李永清带着他做一次就好了。
那假如还不行，你就再问问题就好。
好，
那没问题。然后这段先讲，那我们看这个 slides 哈。So right here, actually, we spend some time discussing the program input. We discuss it, right? We discuss the print function, right? We discuss the print function. This, okay. Here, only some small question is that if you don't like this and you like to change it for a new line, you actually can put a \n over there. Right, this is a minus n, you can actually change the line. Okay, so that in related to the next line, but that actually you just do it for new needed. Okay, this one actually we don't like it here. So that's something we need to take care of. And sometimes if you want to continue to print some data, say print this one K1, K, right? And I say end equals this, okay? Print K1 and this, okay? Look at what is this for, okay? If I put a space, okay? So this one 119, okay? So here it have a space. So if I don't have anything, this with ending with empty string, you will not change it for a new line. Normally, if I have a print, it will change for a new line. But this one, you will not change for a new line. So this one, actually, let's go 100, 100, right? So here, actually, 59 is connected with the 100, right? Because I have empty string. So you have to put a star over there. Okay, so there's a star over there, right? So if I change it for a \n, right? It actually will bend to the next line. So it bend to the next line. So this one actually effectively the same with this. It's the same with this one. Okay, these two are actually the same. So this one is changed for a new line, and then if you don't want to have a new line, you want to keep it in the same line, you put this. Right? But if you put the \n there, it will actually bend to the next line. Okay, so this one actually I committed here because it's not related to our module. Just for you to try. I'll send this file, the whole thing, over to you after the class. Okay. So this one is that. And that actually is user input. We talk about how to get the user input. And then write the first program, we finish that. And these slides I use the Fahrenheit to Celsius to Fahrenheit. Okay, so that actually did the X for input and then run it. So I use different example. Okay, so now the next one we talk about the next module. We start to go into the irrational number. Okay, we start to go into this irrational number. So now what we have in the math module? Math module is a utility module. It gives you pi and epsilon, square function, sine function, and cosine. So for example, actually, if I generate the let me see. Here I already have the math module 0. So actually you can import math and then do square root of 2, square root of 3, something like this, right? So this one actually I include math to generate the square root of 2 and 3. So actually it is square root of 2 or square root of 3, okay? And then here I use this one import. So when you do import, you just get the access to the function, but you still need to put a module name over there in order to run it. So let me clear it, and that's wrong, okay? Okay, so this square root 3 is like this, square root 3 is like this. Now, if I don't want to have this name like this before it, what should I do? Instead of using the import, I should use from mass import. Star means everything. So I just delete this. In this case, I can delete this because it open up the mass module and import everything. So you don't need, if you from mass import something, you don't need to have that mass. Okay. But if I delete this and I try to do this, okay, you see that is red underline. This is not allowed because you open up the module, but actually you don't have the access to it. So square root is not defined. So what you need is like you need to put that mass that something back. Is that okay so far for this?
Yeah.
So I show you two ways of importing. One way is import the function, but without importing the whole module in. Okay. The other one is importing the whole module in. Okay. So they are good or bad. Okay. The one import everything into your workspace, that would be taking more memory space in your computer. Sometimes you will run slower. Okay. If your program is a memory hog, it actually take a lot of memory. But sometimes I like to have this mask import because if the module have the similar to other module, I would rather to have this mask that something that would be easier to differentiate as the same function name but in different module. And you can also do this. You can also import mask as an M. In that case, you don't have mask, you just do this M dot square. You can also do this. So there are three ways of importing a function. I put it here. And you can also, in a mass module, you also have this one, m.pi, mass.pi, and this one, m.epsilon. Epsilon is the exponential number. Are you okay with the epsilon? Ryan, are you okay with this epsilon, E? Are you okay with this constant E, 2.711718 something?
Epsilon 是不是就是那个 scientific notation， 然后什么 Epsilon 是什么啊
Epsilon. Okay, let me talk about this. Okay. First, to study math, now you need to remember these few numbers: alpha, beta, gamma, delta, epsilon, and then like 5 or something. A lot of these Greek letters, right? So this is A, B, C, D something. Delta is like this, right? So this one epsilon is actually E. E in Greek. These are Greek letters. Okay, and epsilon s is E is for exponent. So actually it's actually E to the power x. This E number is called natural log. Natural log logarithm exponent, natural exponent. So that actually is a constant usually used. This one actually, if you see like some constant you put, if you put actually something like 1.2 e minus 10, right? That e actually means 1.0 times 10 to the power minus 10. But this one actually is exponent. The value is 2 point this. Okay, that's called natural exponent. It's called natural exponent, and the value is actually 2.13. 37. So you look at in algebra 2 or above, you have a, if you look at calculator, there's something called ln. It's a natural log. Natural log. Natural log is log e based number x. Okay, that's actually something. I think this is quite important, but so let's see. Okay, it's used in stats and many methods, many science domains. So here, if you don't know about this number, you can type natural exponent e, mathematical constant. Okay, so it's used for, it's called Euler number as well. I'm sorry. It's also called Euler number. It's also called Euler number. So this E is equals this thing. Okay, it's also called this in E number that is, anyway, it's a constant that is this big, okay? And then it is used for natural decay and natural growth, compounding. So it's quite useful in math. Okay, it is also related to trigonometry. So if Ryan had not taken the exponent and the natural log, it's okay. It's okay not to know this right now, but later you need to know this, probably later half of algebra 1. So don't worry about this right now if he actually never studied math. But one thing he need to do right now is to remember all the Greek alphabet. He need to start to remember the, for 7th grader, he need to start to remember all the Greek alphabet. So these different Greek alphabet you need to know. So basically alpha, beta, gamma is A, B, C, okay, but C sometimes match to different things anyway. D is delta, so usually there's a delta airline, something is called delta, okay. So sometimes you see that delta x, this one's triangle actually, that's why triangle called delta, because triangle in Greek letter is capital D. So that's why when the river get out to a ocean, you had a triangle, right? We call it delta. Okay, that's because the shape of this Greek letter is delta. Okay, so usually we have the delta x means the difference in x. So you use the delta, this triangle. And another mathematical symbol, say this epsilon is E because the exponent, exponential, exponent use the E is actually a epsilon. Okay, so basically, if we do like this one, pi, right? Pi actually is a Greek letter. And how comes you use pi? Because pi is actually a ratio, is actually a product. It actually is a product. So use the name P product for this. So product pi also can do pi from 1 to 10. And I, this one actually means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This is called 10 or 10 factorial. Are you okay, Ryan?
Yeah.
Are you okay with this 10 factorial?
Yeah.
Yeah, that actually is also write down as this 10 factorial. Also write down as, if this is n, it will be n10. Okay, that's factorial. And why we use the letter pi is because it's actually is the Greek letter p. Pi is the Greek letter p. So you may also see something that is sigma, right? Sigma is capital S, right? So sigma I equals 0 to 1 to 10. For I, this one is 55, right? Because it's 1 plus 2 plus 3 plus 4 up to 10, right? This is called sigma, big sigma notation. And why we use sigma? Because sigma is capital S, S for sum, pi for product. Okay, so that actually the later for mass. So sigma is for sum. That's why we use sigma. And if you look at the calculus sign is like this. It actually also S. It's a sum. Again, it's a sum, right? It's also sum. And then if you have a differential equation, you have dy over dx. This d actually is also difference, also delta. So delta x, delta y over delta x. Okay, that's the ratio of the deltas. So here, the Greek letter usually, if you look at the physics or chemistry, a lot of symbols actually are using this different Greek letters. Okay, and this one U look like U. This one is not called U. Okay, this one is not U. Actually, is M. It's actually like this. It's M. Okay, so it looks like a U, but it's actually not a U. It's actually an M. This is called micro. So microsecond. And some people it's like US, but it's wrong. It actually is a M as microsecond. So it actually this one called mu. Mu is M. Mu is M in Greek, and it's a microsecond, 10 to the power minus 6. Minus 6. That's M. Okay. So for example, this one per C. Per C is actually used is equal to P as well, and it actually used for pressure. So actually per C is a unit for pressure. Okay. So you need to study these Greek letters for math anyway. That's actually so in the mathematical module, it has the function and everything you need for math. Okay, here you have the absolute function, 14-point integer length of certain data, maximum, minimum, open. These are different functions over here. Okay, and some of them are constants. Some of them are constant. So the math function, whenever you open up the math, you can use those functions. And there are 3 ways to import it. One way is from math import star, but you don't need to write the name in front of it with start. No, you don't need that. And the next one, you can import math, then you need to put math something. Or you can import us m, then you use the m. That will just an m over there. Is that okay for these 3 ways of importing? Okay, that's the math module number 1. Let me bring up the math module number 2. So math module number 2, I can actually just import from math. I just import square. I still can do this, and I can actually save space. But because I import the square, but I did not import pi, so for my pi I still need to do math pi. Is that okay? So this one's number 2, and number 3. Actually, I import everything, so I don't need everything in front of it. So here, let's see. Here I have a part E, right? But this E is from math module, right? So when I print out E, it will be the 2.718. But later I actually assign E equals 1. So when I print the second E, it actually becomes 1. And before this E equals 1, actually is 2.718. Okay, so that's why sometimes import star is not a good idea. If you have the math from math import import math, here you will have math square, math square, math pi, and this E will be a separate variable. You will not change the value for the E definition. Is that okay? Is that okay for this one?
Yeah.
Okay. Then number 4. Number 4 is that I have the max function, right? So this one I try to use that max function to calculate which one is the largest one. And also I have the mean function. So from my max function I import star. So as I mentioned right here, I have a bunch of functions. I have the max and mean, right? If you want to try to find a maximum, and you just put a number as many as you want over there, and then you run. It will give you the maximum as this 11, minimum as the 0. Is that okay so far?
Yes.
But there are quite many functions you can use, okay? Absolute value, you know, right? Absolute value, you know, right?
Yeah.
The built-in function, dictionary, I'll discuss next chapter. Floating point, you convert the things to floating point. ID to give you ages for the object. Integer to convert to integer, we know it already. Length, if you have some list, you convert to length, okay? And this is making the list. And maximum, and opens to open the file, okay? This open and audio is ASCII code number. This is what I'll talk about it later. Power, if you have the x star star y, that will be representing. I will represent. I'm sorry. I will represent x to the power y. Okay. And then range function, I talked about it already, right? Range function, I talked about it today. And then rounding. Rounding is like round to some integer, right? That is fine. Here we have the ceiling and the floor. Okay, do you know ceiling and floor function? And rounding, you know these three, the difference between these three functions?
No.
Okay, let me give you an example, okay? Let me give you, if you don't know, let me give you an example what it is. Let me create a next module file, okay? Okay, again, I use class import everything, okay? And then I have a value a equals 3.4. I have a value b equals 3. I have 3.0. I have value b equals 3.9, right? So here I print this one called round a. And then round b, and then this, and then round b, okay, and then I copy 3 times. And here I do 4. 4. 4. And this one city. This one for city function. City, okay. Then we print. Okay, so 3.4 rounded to 3. Because that's the rounding rule, right? Less than 0.5, it becomes 3, right? Rounding b is 3, rounding d is 4, right? Because up to that. Floor are all 3. What is floor? Floor function means from 0 to 1 is 0. From 1 to 2, not including 2, that's 1. From 2 to 3, not including 3, that's 2. Is that okay? This is floor function. And then which one is ceiling function? Ceiling function means this one solid and here. From 0 to 1, not including 0, that's 1. From 1 to 2, that actually is 2. So blue one is a ceiling function. Red one is so-called the floor function. And let's look at the green one. Green one actually from this one 0.5 minus 0.5 to up to 0.49999, you get 0. From here, 0.5 up to 1.499, you get 1. This green one is rounding function. Rounding function, if you have 499, you will cut this, become 0. If you have 0.500, that would be moved to 1. That's a rounding function. Okay. Flow function, if you have 1.1, 1.5, just shut this, truncate, you only have this. So 1.1, truncate this. 1.9, truncate this. It's all just to 1. That's called flow function. Can you tell the difference between floor, round, and ceiling? Is that okay so far?
Yeah.
Are you sure, right? These three actually have different rounding. So if you look at a house, right? Floor means the lowest one. So whatever extra will be removed, will be truncated. Until you hit the ceiling, you hit the 3 or you hit the 4, and it becomes the ceiling. And the ceiling is like whatever number you have, you just move on to the next integer. Whatever number you have, move on to the next integer. Unless you are 3.0, 3.0 cannot jump before. But 3.0001, that one can be taking ceiling to the upper one. Okay? So ceiling is short for ceiling. C-E-I-L is short for ceiling. Floor is the floor for a house. Okay, and rounding is taking 4 out and 5 in measure to round the number. Okay, so that's the rounding and the ceiling functions. And this cosine with degree to radian, radian to degree. Are you okay with the degree to radian and radian to degree?
No.
Okay, let me explain this one. This one you probably need to know already. Okay, now let's look at a circle. A circle, right? If here, this angle is half of this, how many degrees are this? This is theta. How many degrees for this theta? From here to here. How many degrees?
45 degrees.
45 degrees, good. And then if I have a angle from here to here, how many degrees?
90 degrees.
90 degrees, good. From here to here, how many degrees?
180.
Yeah, here 180. Good. You're quite good over here. Okay. Now, if my length from here to here is 1, right? My length from here to here is 1. Then how long is here this arc? It's 45 degrees, but how long it is for the arc? If my radius is 1, how long is this arc? Do you know?
Okay.
Okay, give you a hint. Making a whole circle, how long it is?
6.28.
Yeah, I know, but okay, 6.28, that's good. That actually is 2 pi, right? That's 2 pi, right?
Yeah.
Yeah, okay. Then how long is this? If you know that a whole circle is something like that, so how long is this? 2 pi divided by how much?
他说 1/8 of 2 pi.
So it's 2 pi over 4, right? 2 pi over 8, right?
Yeah.
That's 1/4 pi. Or whatever number it is 1/4 pi over 4, right? So
yeah.
Okay, so now let's redraw this diagram. Okay, in your elementary school, they teach you this angle is actually 45 degrees, but that's actually called degree. Okay, that's all called degree. And there is another system called radian. For radian to measure the angle. So the radian to take an angle here, we use the radius of 1. The length of this arc is a measure of this angle. So right here, if this is 1, the length of here is 4 quad pi, right? So we call this theta equals pi over 4 and equals 45 degrees. Is that okay?
Yeah.
So then, yeah.
所以意思是说，那个圆周的那个东西叫做 radian， 是吗？
yeah。圆周，只要你这个地方是1的话，那个圆周的长度就是 radian。So if you go all the way to half a circle, right? Half a circle called a pi.
对。
Okay. Half a circle, the angle is called pi. So now here, let's go back to the function, right? Here you have the degree, so it's a radian to degree, and also degree to radian. So you put the pi over there. So let's use Python, okay? Let's use Python to calculate. So this is quite important math, okay? Now let's bring up this here. Let me call it math module 6. Okay, now I actually from math import everything, right? And now I have let me say arc1, okay? Arc1 equals the pi time divided by 4, right? Pi divided by 4 is my 45 degree, right? So I have BG1 equals what? Equals this arc1, no, degree, and then arc1. Is that okay? So let me take the function, okay? Here's the degrees, okay? So the same thing, you know, what do I want to say? What do I want to say here? Same thing, you can do the things like, okay, for I in range 1 to 9, okay? Let's go 0 to 9, okay? And each time I have my arc, okay, my arc equals this same pi times this one, my I divided by 4. Okay, I have this pi times I divided by 4. So the first one is 0. So arc is 0. So my degree is actually what? My degree is actually my arc. Put this over there, right? And the next thing I want to do is that print arc this percentage 6.4. I mean 6.4 f, right? Is this percentage like 6.4. Let me try to be consistent here. Degrees. Okay. And then here put percentage sign, parenthesis is arc and the degree. Is that okay?
Yeah.
Let me see any problem here. Okay, that's wrong. There's a wrong data. Unsupported format. Okay. So then you can see this unsupported format. Okay, there's a unsupported format single quote. Index 17. Wait. Oh, here I miss a F. Sorry. I miss the F over there. Okay. So let's look at this. 0 is 0 degree, right? This pi over 4 is 45 degree. Pi over 2 is 90 degrees. Is that okay? So this will give you a table to convert. But one thing you need to know right here is very useful for math is this. Okay, so here actually you should have a different way of looking at the pi now. Number one, whatever angle it is, if this one is 1, this length will be the theta in radian. Okay, so theta in radian. So the length of this one is like r times theta. So actually, if you have a circle, the radius is r, and then here we have theta. The length of this arc is actually r times theta. Okay, so when the theta is 2 pi, theta is 2 pi, theta is 2 pi, theta is 2 pi, so it becomes 2 pi r. Right? Is that okay?
Yeah.
So this theta is an angle, but if your radius is r, this arc is r times theta is 2 pi r. Okay, let's look at the area again. Area is similar. When you look at the area, this length is r, this length is r. Here we have theta over here. So the length of this arc is r theta, right? And from here, what is the area of this thing? What is the area? I'm sorry, I don't know what it is. Oh, okay. What is the area of this? If here you have r, here this is r theta. What is that? The angle is theta, and your distance over here is r. Then what is this this area of the pi here, this pi size slice of the pi? What's the area over here? Okay, start calculation and give me the formula. Do you know what's the question I'm asking?
Yeah. Pi r squared times theta divided by 300.
Oh, okay. Okay, good. But let me actually tell you a quick way of understanding this. Let me tell you to understand it. A quick way of understanding this. This is r, this is r. So here to here is also r, right? The length of this is r theta. From here, if you look at this guy as a triangle, so the area is a half base is r theta times r, right? It will be half r squared theta. So when theta is 2 pi, this one becomes pi r squared. Check this, it's always true. Use the arc as the base, this r theta as base, and r as the height. Treat it as a triangle. The fan shape, a sector of a circle, the area is this one. The base is r theta, the height is r. Half base times height. It is similar to triangle. You check this, it's always true. So today I teach you two things. One is how to calculate the arc, right? The other one is calculate the arc area, right? Sector. Arc is r theta. The sector area is half r squared theta. Just treat that fan as a triangle. Is that okay?
Yeah.
And if you don't believe it, if you don't believe it, cut into a tiny pieces of it, each one is a triangle. You know what I'm saying? You cut to the tiny pieces of it. This one here. Everyone has the same height, R. It's said that each one has a base, and the sum of the base, you get the same length as R theta. It's similar. It's equal to this one R, and then base of R theta as a triangle. Is that okay?
OK， 其实它那个 big idea math 有
Yeah.
是这样子 approximate 好像哪一个东西的嘛，对不对？
嗯，
拍 approximate 拍，对不对？
对对对，他这个要搞懂，这个是数学非常重要的 concept。Okay, so this one is to give you an idea of how to calculate this. Okay. 确定懂是最重要。Okay, now let's go on. So that's the degree to radian to degree. So today actually you know better about what's radian and what's the angle. But some of the equation, this one is to get this for the hypothesis, whatever that is, right? This one is to get this one to get x and y to get this one h. Okay, get h for x and y. And other than that, some part of them are in the some of them actually are in some of them are actually in algebra 2 that I won't cover. Okay, it's too far. But as you can see right here, actually Python is a good tool for math, and that's why it's the language to deal with big data. Later you will figure this out. Okay, here are a lot of different functions you can later call it. Okay, and this one for trigonometry, but not for us right now. And then here we go to the irrational number. Okay, and I mentioned to you the rational number is what? Rational number is something you can put into A over B format, right? If you can put into A over B format, means you can compare A to B. That's a measurement result. And irrational number is something you cannot calculate. So then since you cannot calculate, you cannot measure, then how comes this number come out? That because you have the equation. So people invent the equation to calculate it. People invent the equation to calculate it. So right here, let me check conversion 0. This one my root. Okay. This one my root. Okay, my root is my way of calculating root. There is an equation called this. Okay, if you check the internet, there is equation here which is called SQRT of 1 plus x. Okay, to get the expansion for this this one, square root of 1 plus x. Okay, so if right here I put a 1, if I put a 1 and then I have a good expansion, I should be able to calculate square root of 1 because this function is f. I'm sorry. This function is f of x equals square root of 1 plus x, right? So f of 1 will be equal to f of square root of 2. Okay, that's the Taylor's expansion for this. Okay, since we don't know how to calculate square root 2, so there's somebody who are smart coming out with this expansion of these. So this expansion of these is called Taylor series of these. And each of the component, the coefficient over here, is the following table. It's the following table you see right here. So if you have f of a, it actually is 1. Second one is 1 over 2 times x. Third one is 1 over minus a, something like that. So you keep going on to find whatever term it is. So in my solution right here. I find out the first term, second term, third term, fourth term, fifth term, fourth term, fifth term. So you keep going on to have the exact number for this square root 1 over square root. Okay, you keep going on. So the version I have here, let's say, is this version. But there is an ideal version, so I have this one, this minus the ideal version. The ideal version is 1 over x. Two different things. I take opposite value that show me the error between my solution and the real good solution. Okay, that's my root. And let's see how good is my root. Okay, so here I have the square root of 2, and then I compare this one with the function given by master pi. Right, this square root 2 is given by master pi, and this my root is my way of calculating the square root of 2. Okay, and then here has the square root of 1, 3. That's a 1.3. So I try to compare it as well. Okay, let's run this. So here you can see my square root of 2 has the 0.011252 error, right? But square root of 2 should be 1.414 something, right? So there's a 0.01. And this one square root of 1.3 is very close. It's very close. So if I keep writing more term over here, my square root function can be mimicked by this function. If I keep writing this whole term, the table that given by the internet, right? Here I have the first term 1, second term 1 over x over 2, right? Third term 1 over a minus 1 over a times x squared. Fourth term I have 1 over 16 times x cubed, right? Fifth term I have this, right? And then the next one I have this one, 7 over 256 times x to the power 5, right? Now let's add this next term. Next term is 21 over 11024 minus. So it's minus and then 21 over 1024, right? Times x power 6. Right? If I add this term, see if our equation is closer. Okay, minus 1 over this and then times 6 power 6. Okay, let us see if this one improve. Okay, okay, does it improve? Yeah, it actually get better, right? So if I have as many as possible equation from this table, I should be able to get to very fine result. Is that okay? I should be able to get a square root of something in very fine result. So that's why I talk about, I give this example, just want to let you know that your rational number actually is always a approximative value. It can be figured out if you have good equation. You keep chasing it one by one, calculating it to the very fine digit. You may be able to find down to like 10,000 digits or something. Like some people try to get pi, right? So actually, you can check like the largest pi digits. Okay, some people spend their whole life to do like 2 quadrillion digits. Okay, and it is an irrational number. So some people come up with his own equation trying to continue to calculate pi down to the 2 quadrillion digit. Okay, for me, I don't want to waste my life to do that, but at least I know that if my approximation is good enough, my irrational number I can get to a very fine and close range. Is that okay? So let's look at the number, the counting number, integer, whole number, negative number. You can count by your finger, count by your abacus, right? Second one, the rational number you can measure. Something you can measure, that's the rational number. And this one, your rational number, you cannot count, you cannot measure. The only thing you can do is that find an equation, try to approximate. Okay, That's irrational number. So irrational number you have to depend on what? Depend on this messed up pi. You have to find the number from here using that equation. Okay, and then this one to find this function I already defined. Okay, I use the example of the kilogram to whatever, and then last section for complex number probably too hard right now.
好，所以 Eric， 我们今天要不要就上到这里就好了？
Yeah， 上到这里。
但他不能再上更久了。
我刚才快坐不住。所以其实你假如说那个要 private lesson， 可能一个半小时可能还好一点，2个小时恐怕耐力不够。
没有，其实我觉得是因为他有一点到中间有一些地方跟不上，对不对？因为他并没有先练习嘛，所以当你在用那些方选的时候，他好像有点不熟嘛，对不对？
对。
所以你在那里改到最后，他就已经有一点傻了。但是我因为反正到最后有录的，最后叫李永清稍微看一下，然后
让他一步一步做了，跟着做。
对。
然后再做不出来有问题，我再带他做，然后或者他爸爸带他做，对不对？但是你可以看到这个好像几个数学，你看第一个 chapter 好像只是算简单数论，可是事实上还蛮多东西在里面。对。然后我们基本上现在这个是 lecture 1嘛，对不对？到 lecture A、B、C 到 D 的时候，我们就把这个所有的派上program弄完，再下去做那个就是那个叫什么 AOPS 那边的数学，用 Python 去写。但是这个
你的意思是说，你再不知道哪一个 lesson 就会把 Python 用到 Math 的部分都教完？
就是不是 Python 基本语法弄完了
？OK。
然后后面就是用 Python 去学数学，不是用数学来学 Python。一开始我们是用这些简单数式来学 Python， 然后弄了大概到 Unit 1结束 ，Unit 1就4个。我现在上次已经7到3号了嘛，到 C 了嘛。第一，我最近会把它完成，那就是已经 Python 基本小朋友需要知道的那个 Python 大概就够了。但是后面比较怕大家不知道，是说你这些什么 natural number 也搞不清楚 ，complex number 也搞不清楚，那你后面什么计算基本上也没办法算。
complex number， 你刚刚不是说 complex number 他们不懂吗？
一般他们是到 Algebra 2才会教，但是他只要有兴趣，我可以再另外教他了，没关系。找个时间再教他，他只要对那个有兴趣。
没有，但是你后面的还会用到 complex number。
很后面到应该短时间不会，会到那个什么 Algebra 2的地方才用到，还有三角几何那边才会用到，三角函数那才会用到，所以短时间是不会。短时间主要是在做除法的那个比例选那种。但是他就今天就是你让他做一个那个什么，我们已经有那个 Fahrenheit to 那个 Celsius 嘛，你让他做那个，不要看这个 node， 自己做那个那个摄氏到华氏到摄氏的转换。
但是我觉得他应该要再先把你上课的那一个再好好的先学会。
对，就是说那 kilogram to 那个 pound 跟 pound to kilogram， 他先看。对。再来他自己写一个作业，就是不要看我的 node， 直接把那个摄氏转华氏转摄氏做出来。那同样你就从0度开始到100度就好。
0到100度，
对，就0、10、20、30、40、50这样到100度。
你说的那个是像是 range 这样，是不是？
对啊，就用那个 range 就可以了。
range 是0到100，对不对？
对。
好。
那华氏，你比方说从0到220吧，240。因为华氏一次20这样加就可以了。这当他的作业就对了。他这个搞懂，其实大概就那个主要写方言跟一个简单程式就搞懂。
那你说 Celsius 是一次多少加？1加12这样加
？10。
Celsius 也是10啊。
10、10、20、30、40这样加，然后你去转成华氏，但是华氏那边就0、20、40、60、80这样，一直到240度，因为摄氏100度是212度，所以你加到240这样应该可以。
好，真的就是 homework 对不对？所以我不用去 Piazza 看什么 homework， 就这个就对了。
Piazza 有 post， 不过那个也是类似的东西，差不多对，你就做这个就可以了。
没关系，我先把这个搞清楚，因为其实你写的那个东西其实蛮好玩的，但是就是他要下去做，然后就是要练才晓得。而且他
因为我现在我不想要教你课本刚刚一样的algebra 1，因为只要我教你那个 big idea 的数学，那没什么意思，对不对？
嗯哼。
所以我刚刚比方说看到这个那个拍那个比例，对不对？我尽量跟他讲清楚什么叫做拍，不要只是那个圆周率对那个直径。那你这样子你搞不懂说那个拍到底有什么用？但是假设我刚刚讲的东西他有听懂，就是说那个 r 的长度就是它的角度，那他以后就很容易看懂说哦这个长度多少，那你的 r 变长了，所以它那个 r 西来跟着变长，对不对？那个长度就变长。那你同样的，你那个扇形的角度，你只要是那个知道它是类似像三角形这样 ，radius 找出来 base arc 之后常知道就是 r 西的，那两个那个扇形就不用再回去讲说哦这个212度，然后除以360，然后再转半天去算那个 pi r square， 那你就浪费很多时间了，对不对？那扇形面积就会很快算出来。Okay, bye now.